Chapter 10 covered the geological processes of the Earth. Chapter 15 goes further into depth on the non-renewable resources we obtain from Earth. I covered minerals and rocks in the Chapter 10 video. You should recall that a mineral is a natural material found in Earth's crust that has a set chemical composition. The three major types of mineral resources we find on Earth are metallic, non-metallic, and energy resources. Minerals and fossil fuels are mined from the Earth's crust. The rocks recovered during mining that contain enough of a given mineral to be considered profitable are considered ores. These ores are extracted until it is considered no longer cost-effective to mine for the mineral resource. At this point, the mineral is said to be economically depleted. Scientists have many ways to determine whether or not mineral resources are found underneath the surface. These include aerial photos and satellite images to identify the typical geological features associated with these deposits, as well as looking for changes or fluctuations in the Earth's magnetic or gravitational fields due to magnetic minerals. The U.S. Geological Survey, or USGS for short, has characterized minerals into 4 different groups. Identified reserves are areas that have known deposits and direct evidence to back it up. Undiscovered resources have some evidence for them, but the exact amount or location of these minerals is unknown. Reserves are easily identified like identified resources, but these are actually easily accessible and affordable to extract, while identified resources may not be. Consider it a subcategory. Last, we have everything else. It's unknown, so it is just called other resources. In order to extract these minerals from the Earth's crust, we mine for them. Subsurface mining requires the digging of a tunnel system to obtain minerals deep below the surface of the Earth. Surface mining is used for minerals that are much closer to the Earth's surface. The method of removing a resource is selected based on factors such as the depth at which the resource is located, the amount and stability of the material that must be removed to reach the mineral, also known as overburden, the topography of the area, safety, and economics. One last thing to know is that spoils or gangue are it's literally just the waste material from the mining techniques. In open pit mining, a huge hole is dug using explosive and heavy equipment, and the deposit is removed. Dredging for minerals is much like the dredging we saw in the water unit to obtain aquatic organisms. Dredging drags chain buckets and drag lines across the floor of the body of water to obtain minerals. Strip mining is used to remove deposits that lie in horizontal beds close to the Earth's surface. First, the land is clear-cut, and the overburden is removed and set aside with explosives and heavy equipment yet again. The deposit is then removed with huge power shovels, and the overburden is replaced. If the area is flat, then area strip mining is used. If the area is hilly, then contour strip mining is used. Last, we have mountaintop removal. Here, coal seams are exposed by removing the top of a mountain using explosives and/or heavy machinery. The material removed is dumped into adjacent valleys, sometimes burying forests, rivers, and streams. The coal is then removed with power shovels or bulldozers. Mining operations cause significant damage to the environment. The first step of a mining operation requires that the habitat above the deposit be destroyed by clear-cutting forests and removing native vegetation. This requires a lot of energy before the operation even truly begins and scars the surface. Even after overburden is replaced, soils will no longer be layered into the soil horizons that would allow true restoration of the native habitat. Streams and rivers in the area are clouded by sediment and in some cases are buried. Wastewater that flows into local waterways is contaminated with hazardous chemicals. Acid mine drainage occurs when sulfur compounds in mine waste are exposed to air, oxidize, and dissolve in rainwater to form a sulfuric acid solution. The acidic runoff enters waterways, causing significant ecological damage similar to that of acid rain. There are 5 major laws relating to mining that you should be aware of. The Mining Act of 1872 encouraged the exploration and mining of mineral resources on public lands. There's actually a lot of debate about whether or not to modify this law because of the potential damage mining causes in these locations. The Mineral Leasing Act of 1920 requires leases for public lands before someone can mine for minerals. The next 2 are laws we discussed in the waste unit, so they should be familiar. CERCLA, or the Superfund Act, helps fund brownfield cleanup, which includes past mining sites. RCRA puts regulations into place about mining waste. Last, the Surface Mining Control and Reclamation Act was put into place to force miners to reclaim the land after they are finished. This means that these lands must be put back as close to their original state as possible. With subsurface mining, deep vertical mine shafts with horizontal tunnels branching off are blasted into the earth to remove deposits that are too far underground to reach by surface mining. While there is less habitat destruction on the surface, subsurface mining is considered very dangerous. Miners run the risk of cave-ins, explosions, and potential lung diseases as well. The term fossil fuel refers to solid, liquid, and gaseous forms of ancient vegetation or animal matter that can be found buried inside the Earth's crust. These fuels include coal, oil, and natural gas. All of these resources are extracted, processed, and used at a power plant to generate electricity. All of these power plants follow the same steps. The only difference is the fuel source. Power plants need a source of heat. Burning coal, oil, and natural gas supplies this source of heat. The heat is used to boil water, which eventually creates steam. The steam rises and spins a turbine, which is connected to a generator. The generator generates electricity, hence its name, and the electricity is then sent from the plant to your house or business. The steam is condensed and used over again. Coal is the most abundant fossil fuel and is used to produce most of the world's electricity. It is a mixture of carbon, hydrogen, and oxygen. Coal formation begins with peat, which forms from an accumulation of partially decomposed plant debris in waterlogged anaerobic conditions. After being buried by millions of years of sediment accumulation, heat and pressure squeeze the water from the peat and initiates a series of transformations into the ranks of coal. In order from youngest to oldest after the formation of peat, the ranks of coal are lignite, bituminous, and anthracite coal. Coal is indeed the most abundant fossil fuel. It accounts for 50% of the electricity in the United States. Overall, it has a relatively high net energy yield, meaning that it takes less energy to obtain and burn than it actually creates. There are currently subsidies put in place to keep prices relatively low, and it is a stable resource, meaning that it is not explosive or harmful if it is spilled. But when coal is burned for electricity purposes, it releases dangerous greenhouse gases and toxins such as carbon dioxide, nitrogen oxides, mercury, and sulfur dioxide. There are scrubbers that can be added to smokestacks to eliminate some of these pollutants, but it doesn't eliminate all of them. Coal also creates dangerous byproducts such as fly ash and boiler residue. These are both carcinogens. Mining processes for coal disrupt land, and the pollution can further progress global warming. What does this look like in the news? The Clean Coal Campaign. Coal companies have been fighting hard against harsher pollution regulations on the mining industry. It makes sense because it would hinder their business. Unfortunately, there's a lot of denial from the coal industry on the effects of the industry itself on global climate change and air quality. As a result, there's been a push of the term clean coal. Well, it sounds clean, but it's not really that clean. There isn't a brand new form of coal we have discovered or created in a lab. This is literally just a pretty way to say that we use scrubbers on smokestacks to remove some of the air pollutants. It's just for show. It's not a new idea. We have been placing pollution controlling devices on smokestacks for decades now. But now that they have given a nicer name, it makes it sound better to the typical American. Critics claim that there's no way to completely remove the pollutants, and a preventative approach is key here. Remember, prevention is key. We have said it multiple times in this class. The price of coal also doesn't include the environmental cost because of governmental subsidies. Yes, the price is lower than other forms of energy, but it is artificially lower. Crude oil is formed from the remains of ancient marine organisms that were buried beneath sediments and subjected to high temperatures and pressure. Oil is a mixture of many different liquids and gases whose components are used to provide energy for a variety of purposes. Because it is a mixture of liquids, crude oil requires a separation and purification step between extraction and use that is not required of the other fossil fuels. This step takes place at an oil refinery, and it makes use of a process called fractional distillation, which separates liquids based on differences in their boiling points. Oil can also be found in shale rocks and tar sands. Shale rocks are not very economically sound as sources of oil, but tar sands show a little more promise. Oil is also considered fairly inexpensive due to governmental subsidies. It is easily transported, has a high energy yield, and is a very versatile product. There's also an ample supply of it, but currently world sources are declining quickly. There is land disruption and water and air pollution. Oil spills destroy marine and terrestrial habitats, and the politics surrounding oil are concerning. One of the biggest pieces of news we see with oil right now is ANWR, or the Arctic National Wildlife Refuge. Due to the want for independence from the oil-rich Middle East, there has been a call for renewed oil exploration and drilling in environmentally sensitive areas. Anwar is one of these locations. Anwar is a national wildlife preserve about the size of South Carolina, found in the northern parts of Alaska. There are areas said to be completely untouched by human hand in this reserve. Unfortunately, this refuge is found over a large oil preserve. There is currently a pipeline running along the outside of the refuge border, pumping oil from the reserve to the Valdez port. Valdez probably rings a bell in your head because of the 1989 Exxon Valdez oil spill. It decimated marine habitats along the coast of the Prince William Sound. Currently, there are massive debates as to whether or not we should start drilling for oil inside the actual refuge itself instead of just along the border. Mostly methane in composition, natural gas is formed and found alongside crude oil and coal. Like coal, it can be used in power plants to produce electricity, and it is also commonly used for cooking and space heating. Burning natural gas produces less carbon dioxide per unit of energy than either of the other fossil fuels. Because it is a gas, natural gas is difficult to transport great distances. Pipelines are used to transport natural gas over hundreds or thousands of miles, but they are expensive, unaffordable in many developing nations, and subject to sabotage. Natural gas can be converted into liquefied natural gas, or LNG, when placed under pressure at low temperatures. This makes it more convenient to transport large distances, but requires energy to compress, refrigerate, and transport the gas. There is less pollution produced when natural gas is burned as compared to coal. Burning natural gas produces carbon dioxide and water vapor. The pipelines I brought up have already been put in place in the United States. There is a high net energy yield. It's relatively inexpensive, again, yet due to governmental subsidies. And the extraction of natural gas isn't as damaging as coal or oil. But it's hard to contain, and it is an extremely explosive gas. Because of this and the fact that gases are more spread out than liquids, natural gas has to be transported in highly pressurized containers. These aren't cheap. While the burning of natural gas doesn't lead to air pollution, the processing of natural gas releases hydrogen sulfide and sulfur dioxide. The methane itself is a greenhouse gas, and pulling the natural gas from the crust can potentially lead to land subsidence or the sinking of land. The biggest news with natural gas at the moment is hydraulic fracking, or just fracking for short. Fracking is a process to remove natural gas by mixing chemicals with water and pumping it into a well under high pressures to fracture rock in order to release the gas. It is quick to set up and lasts for decades, allows us to remove reserves of natural gas that were previously economically unattainable, and lowers our dependence on global energy sources. But the chemicals are dangerous and can infiltrate groundwater supplies. The byproducts created by the interactions between the chemicals, water, and any newly dissolved material can be toxic or radioactive. There's also evidence that it can lead to local geologic instability. Like fossil fuels, nuclear energy is a non-renewable resource. Nuclear power plants use the same method as those fired by fossil fuels to generate electricity, namely by heating water to produce steam, which rotates a turbine connected to a generator to produce electricity. Nuclear power plants use the process of nuclear fission rather than combustion of coal to heat the water that becomes steam. The most commonly used nuclear fuel is uranium-235, but uranium-238 and plutonium-239 are used as well. Nuclear fusion is a new and upcoming form of energy production that we are seeing sprouting up in places like Germany. It is called the nuclear of the future. 20% of the electrical energy in the United States and 16% worldwide comes from nuclear power plants. Nuclear releases no air pollution whatsoever if it is operated correctly. Water pollution and land disruption are low as well, but there is potential for dramatic disasters and can be used to harm others. There's also the issue of hazardous waste concerns and where to place it. A proposal to open the first high-level radioactive waste repository in the world at Yucca Mountain, Nevada, has been delayed due to safety and security concerns, and probably will not be opened anytime soon. There are also concerns with thermal pollution and a low net energy yield. In Chernobyl, Ukraine, a meltdown in 1986 exposed millions of people across Europe to dangerous levels of radiation. Cancer rates in the surrounding regions skyrocketed, and the cleanup costs were estimated at $400 billion. There are still cleanup measures being enacted today. The reasoning behind this event has been blamed on poor design and human error.